All right. When we're translating verbal expressions into algebraic expressions, we're going to use those keywords of, okay, we've got two more than is addition, 4 times, that's going to be multiplication, and then the cube of a number. Okay, anytime you see a number, that's just a variable. What letter would you like to use? K. All right, cool. We'll use K. All right, so we've got K, the cube of K. So that's going to be K cubed. So we've got 2 more than 4 times K cubed. So 2 plus 4K cubed. Now this is just an expression. There's not going to be an equal sign unless it says is something, or yields, or gives, one of the words that mean equality. Okay, the quotient is division. Okay, and it's always the first thing listed divided by the second thing listed. So this tells me first divided by second. 5 less than. Now when you do 2 more than, you can put the 2 in front, it could be 2 plus, but when you say 5 less than, it's subtraction, and that means the 5 less than goes at the back. So this tells me minus 5. A number, what letter would you like to use this time?
Q.
Q, all right. And 12. So this is going to be this expression here, 5 less than a number, divided by 12, because 12 came second. So for 5 less than a number, we wouldn't say negative 5 and then nothing there in Q, because we're subtracting, so it's Q minus 5. And that's divided by 12. And in algebra, we stop using, this symbol for division, and you guys should pretty much all be familiar with this fraction bar as division. So, just a refresher. Okay, going the other way. You don't have to be fancy. You can be very literal. 6 times a number. Or you could say 6 times x is 72. You could get super fancy if you wanted. You could say the sum of a number and 15, or you could just say a number plus 15. Is 91. So you don't have to be really fancy when you're going from an algebraic expression to words. There's multiple options. When you're going from words to an algebraic expression, there's only one option. The properties of equality says substitution underneath there, so you have that on your paper already, but substitution, okay. We use these to solve equations even though we're not necessarily saying, I'm going to use the symmetric property now, but we are using the properties. So the reflexive property, reflexive is like a reflection. So both sides of the equal sign have to be identical. So with an actual number, 6 equals 6. 5 equals 5, 100 equals 100. You have to be identical on both sides. With symmetric, that's more like if x equals 3, then 3 equals x. We're just rotating around. And we use this because sometimes when we're solving an equation it looks like that, and then we go, "Ooh, that's not pretty," so we just turn it over and put the x in front. Because it's prettier. Transitive and substitution are very similar. Transitive takes you like through something to get to the end, whereas substitution is just a straight replacement. So transitive, if x equals 4 plus 1 and 4 plus 1 equals 5, that means x equals 5. So with transitive property, these two will always match. The 4 plus 1 and the 4 plus 1, those match, and then you take the other two, and that's the end. So basically we're taking out the middleman. The middleman being 4 plus 1. And with substitution, if I know x equals 3, I can take x away and put the 3 in. So 2x would be 2 times 3, so it's 6. So I can take things of equal value. If you need 50 cents, you really don't care if it's 2 quarters or 5 dimes, right? You have 50 cents. So that's the same as that. We don't care if we have an x or a 3, they're the same thing. So we can replace them with each other. What are addition and subtraction properties of equality? These are actually two different properties, but I figure they are basically the same thing, so I'd combine them. There's the addition property of equality, and there's the subtraction property of equality. And that tells me if two things are already equal, and I subtract the same thing from both sides, it's still equal. Also, if I add the same thing to both sides, it's still equal. If I take x and I say it equals 10, well, if I take 5 away from both sides, it's still going to be equal because I did the same thing to both sides. I took 5 away from each of them. Usually the way you see that, though, is like x plus 3 equals 7, and then I take 3 away from both, so I get x equals 4. But what I've done is I've taken 3 away from both sides. That's subtraction. Or addition. If I have x plus 6 equals 9, if I take 6 away from both sides, it's still equal. I take the same thing away from both sides, or added the same thing to both sides. Make sense? We also have multiplication and division properties. I notice I keep saying real numbers because right now we're in the real number system. And so this is true for real numbers. Later on in further chapters, we won't be in the real number system anymore. We're going to go into imaginary math. What this says, if I have two things and they're equal, if I multiply them by the same thing, still equal. Or if I divide them by the same thing, still equal. So for example, if x over 3 is equal to 2, and then I multiply both sides by 3, still equal. Or if 5x equals 15, and I divide both sides by 5, still equal. So we have single step equations, or equations that can be solved in one step, and whatever they did, we do the opposite. So they add, we subtract. They subtract, we add. Always both sides. They've multiplied, so we're going to divide. They've divided, looks like a fraction, it's not, it's division. So we're going to multiply. Oops, not times 4. Times 7. Multi-step means we solve them in more than one step. So we have a lot going on here. The first thing we want to do is we need to get each side of the equation as simplified as possible before we start moving things around. So the first step is always going to be distribute if necessary. And how will you know if you need to distribute? Well, if you have this parenthesis thing happening. So I'm going to distribute this 5, and I'm going to distribute this 2. And that is going to give me 5x plus 15 plus 2 minus 2x equals 14. Okay. Then we're going to collect like terms. Sometimes we have to do that on both sides of the equal sign. In this case, 14 is already by itself, so we don't have to do anything to it. It's just hanging out. So we only have to collect like terms on one side, and I have 5x minus 2x. So it gives me 3x, and 15 plus 2 is 17. Okay. Now, in mathematical operations, we always do multiplication or division before addition or subtraction. But since we're trying to move backwards to undo what has been done, we're going to do the addition or subtraction first and then multiply or divide. So we're going to subtract 17 from both sides. And that will give me 3x is equal to negative 3. And then to get rid of that 3, I'm going to divide. And so x is negative 1. Right, sometimes we have variables on both sides of the equation. The steps are pretty much the same as far as initially. We just have to move things both ways. So the first step is still going to be to distribute if necessary. Alright, so I'm going to distribute that 3, and I'm going to distribute that negative 5. Okay, and my next step is still going to be to collect like terms. Okay, so on the left-hand side, I've got 3x minus 5x, so that's negative 2x. And I have negative 12 plus 40, so that's positive 28. is equal to 10x plus 4. Okay, now I need to make a decision. I want to move all of my variables to one side and all of my constants to the other side. So I can either add 2x to both sides, or I can subtract 10x from both sides. So do you want your variables on the left? Because some people really like their variables to be on the left. Or do you want your variables to be positive? I have a vote for positive, so we're going to go with that. So we're going to move variables to one side. And it doesn't really matter which way you go. You'll get the same answer, but we had a vote for positive variables, so we're going to go with positive variables. So I have 28 is equal to 12x plus 4. And then I'm going to move my constants to the other side. Okay, and constants are just numbers with no variables on them. So I'm going to subtract 4. And that gives me 24 is equal to 12x. And then I'm going to divide. And that gives me 2 equals x, which is perfectly acceptable. But if you're like me, 2 equals x just kind of makes me go, eh. So I fix it. But you don't have to. At this right here, this step that I just did, that's just a preference thing. Yes?
Why was the 40 positive?
Negative 5 times the negative 8. So
That's
when
a
you...
negative That's a negative 8?
Yeah, I know it turned out really small. I apologize for that. That was a negative.
Oh.
If that's confusing, sorry about that. Yeah, so it was the 2 negatives gave me the positive. Good question, though. Thank you. Absolute value is distance. And it's distance on a number line from 0. And distance. If you think about distance, like let's say I go walking a mile, and then after I hit a mile, I decide to start walking backwards. And I walk another mile. Even though I was walking backwards, I didn't like negate the first mile I walked, right? I walked 2 miles. So distance cannot ever be negative. It doesn't matter which direction you go, you're still traveling a positive amount of distance. So absolute value, because its distance, is always positive. So if I take the absolute value of 2, well, that's 2. And if I take the absolute value of negative 2, well, that's also 2. Because if we're on a number line, I'm 2 units or I'm 2 units, right? You don't have to draw that if you don't want to. But it's always positive because it's a distance. Well, because of that fact, if I say the absolute value of x equals 2, and both 2 and negative 2 give me 2, x could be either 1. And because x is an unknown, I have no way of knowing if it was meant to be the positive 1 or the negative 1, so I have to tell you both. Because it could be either 1. And we do the same thing here when absolute value of x equals 4. Well, that means that this inside could have been 4 or it could have been negative 4. 4. Okay. And if I have 3x, that means 3x could be 18 or negative 18. But I want to know what x equals. So I divide them all by 3. So that means x is 6 or negative 6. And if writing it with the or and dividing it 3 times is a little confusing, because I can see how that might be a little confusing. Let me pause this. Hide. Solving with this or in the middle, because some people don't. You could instead write 3x equals 18 or 3x equals negative 18. And then solve them separately. So this, again, you're going to get the same answer. See, same answer. It's just a matter of visual preference. So if you don't like this, where you're doing 3 things at once in the same problem with an or in the middle, then just split it into 2 different equations and solve it that way. And then we have absolute value of x equals negative 5, and absolute value is always positive. So anytime you have absolute value by itself, and then it equals something negative, you have nothing to do except write this. Because absolute value can't be negative. Inside the absolute value, that whole expression, so in this instance, 2x plus 3, this whole expression will either be positive 9 or negative 9. So I have to split it into 2 equations. One with a positive answer, one with negative, and then solve each. And we can do that in one combined, like the 3x, or we can split it. So I'm going to do 2 examples, one with it combined and one with it split, and then you can pick the way you like better. So with it combined, 9 or negative 9, and I have to subtract 3 from, actually, you know what, I'm sorry, I'm going to change that. I'm going to do it not combined first, and then combined. Hopefully that's not confusing. There. So I have 2x plus 3 can be 9, or 2x plus 3 can be negative 9. So then I'm going to solve each of these individually. So I'm going to subtract 3 from both sides here. And that gives me 2x equals 6. Divide by 2. And I get x equals 3. That's my first answer. Then I come over to the second equation, subtract 3 from both sides. I get 2x equals negative 12. Divide by 2. X equals negative 6. Okay. With absolute value, 95% of the time, you will always have 2 answers. I will show you the examples of when you won't in a second. But 95% of the time you have 2 answers, always. So we can do it this way, where they're split into 2 separate, completely individual equations. Or if you don't like to write a whole lot, we can combine it. So this 4x minus 10 is going to be either positive 14 or negative 14. So I can write 4x minus 10 equals 14 or negative 14. And I want to add 10 to both sides of the equal, but I have to account for all three spots of what's happening. So I'm going to add 10 three times. And so I get 4x equals 24 or negative 4. And then I'm going to divide by 4. Again, I have to do that to all three parts. And I get x equals 6 or negative 1. Sometimes you have to get the absolute value by itself first. So when that happens, before we can split it, it has to be absolute value equals number before you can split. So let's see. And then there will be stuff in there. So absolute value equals number. So the first thing we want to do then is get rid of this plus 8. So I'm going to subtract 8 from both sides. And I'm going to get the absolute value of 3x minus 2 is equal to 31. So, and you always want to, before you decide something's a no solution, because like if this had been negative, but this had been negative 48 or something, then it would have ended up being positive. So you always want to make sure its absolute value alone is equal to a number. Then you decide, first of all, if there's going to be a solution, and then if there is, then you solve for it. So all together with an or split into two separate equations? All together? So I have 3x minus 2 is equal to 31 or negative 31. So I add 2 to both sides. Well, 3 sides. So 3x is equal to 33 or negative 29. And then I divide everything by 3. And I ran out of room. So x is equal to 11 or negative 29 thirds. 29 does not divide by 3, so I just left it as a fraction. Perfectly acceptable answer. As long as your fraction doesn't reduce, you just leave it how it looked. Sometimes there are variables on both sides. And when this happens, we do need to split it into two separate equations. So we'll split. And I'm going to write it here and here. Okay. So I've got x plus 10 is equal to 4x. I was in my own way. 4x minus 8. And x plus 10 is equal to negative 4x minus 8. That whole expression, 4x minus 8, needs to be made negative. Okay. And then we're going to distribute that negative. So I get negative 4x plus 8. Okay. Then we're going to solve each. So to solve this one, I'm going to subtract x from both sides. And I get 10 is equal to 3x minus 8. Then I'm going to add 8 to both sides. And I get 18 is equal to 3x. Divide by 3. X will be 6. Then I'll come over here and I'll add 4x to both sides. And I will get 5x plus 10 equals 8. And then I will subtract 10. And I get 5x equals negative 2. Divide by 5, and x will be negative 2/5. And we are not done. When you have variables both in and outside of the absolute value, most of the time only one of the answers you get will be a true answer. So we actually have to go back and plug them in and see which one works. So step 4 is to do that. So we're going to plug in our answers and check. So I'm going to do that down here. Okay, so I'm going to plug in the 6 first because that one's easy. So I get the absolute value of 6 plus 10 is equal to 4 times 6 minus 8. So this is the absolute value of 16 is equal to 24 minus 8. So 16 equals 16. This is true. So that one's good. If I plug in negative 2/5, I have negative 2/5 plus 10, absolute value, sorry, I have to plug it in, is equal to 4 times negative 2/5 minus 8. Okay, negative 2/5 plus 10. 10 is 50/5. So I have 48/5 is equal to 4 times negative 2, which is negative 8/5, minus negative 40/5. So that gives me negative 48. Absolute value does not equal a negative, correct? So this one does not work. So this is my only solution. So anytime you have a problem with the x's both in and outside of the absolute value, you're going to have to do this last part. On these, you don't have to. But on the ones like this, you're going to have to check because you're only going to have one answer that's true. And I wish I could say something like, it's always the whole number. But that's not the case.